Okay, let's get started. Hi, good afternoon, everyone. Thank you very much for making the special effort to make the journey and show up in the room. It's really, really appreciated. Thank you. And I really hope to make your journey worthwhile here and share some insights into how we have solved a very big business problem that most of us have in our day-to-day tech industry, right? So before we get started, it's again a pleasure to be here in San Francisco. A gateway to Pacific is what it is called, and I know this place is now teeming with a lot of tech enthusiasts. The maximum number of tech enthusiasts are in and around this area, so it's a great place to be and exchange ideas, learn new things. Always a pleasure. Thank you very much again for the pleasure of your company here. So let's show with a quick show of hands how many of you have felt like technology, compliance, and innovation are acting as blockers rather than enabling each other. Anyone? Okay, that's a quite a good number of hands. So that exactly is the loop we have actually broken in Morgan Stanley. We have converted that loop. We broke that loop and converted it into an express way where we can resolve issues for our business using technology, ensuring 100% compliant solutions. I'll take you on a journey with me on into Morgan Stanley Wealth Management, where we have enabled a unified platform using the power combo of Databricks and Dataiku, and how we have enabled a huge set of users to be able to extend their boundaries and deliver solutions. So before I get started, my name is Raja Lanka and I am an executive director at Morgan Stanley with 14 plus years of experience at Morgan. I've been in various different office locations in Morgan Stanley, and I'm currently based out of Atlanta office, where we have acquired E-Trade and we have formed a significant presence in Alpharetta region of Atlanta. I know data analytics, machine learning, all of these could be a very serious topics. Okay, the topic itself is serious, but we can have some fun while we are learning about it, and I'll make sure that we keep this session lively, and given this small audience, we can even make it interactive if you all wanted to. For those of you that are not familiar with, I represent Morgan Stanley, a global leader in financial services with a legacy spanning nearly a century. So since 1935, Morgan Stanley has been operating in investment banking, wealth management, and institutional securities. And we have always strived to be on the cutting edge of technologies and with a commitment to innovation and excellence. For us, delivering best-in-class solutions for our customers is of utmost importance, and the way we do it is we always stay ahead of the curve and innovate solutions. And just to give you an example or a metric about it is, we were the first financial firm to launch a machine learning model into production that has given us the next best action for our customers. What do we say to the customers? How do we interact? That has been decided through a machine learning model that has given us the top 5 ideas we can discuss when we call up our customer. You can read more about it. If you Google Genome and Morgan Stanley, you can read more about it. So that's led to a individual based marketing from a segment based marketing, and we were the first ones out of all the financial firms to deliver it. But at the same time, we also understand that in our mission to give a best-in-class service, we also have to make sure that in today's world, technology and the finance have become inseparable. They are joined at the hip and they cannot go in either direction, right? They both have to have the same kind of journey. So before I dive into the solution, I just want to establish what are some of the core challenges we have been facing and how we have identified those and resolved those. So some of these challenges, I'm sure you have heard about them in the last 24, 48 hours, and you have experienced yourselves in your day-to-day life, in your whatever firm and whatever domain you might be coming through, like especially something like a talent management or the market competition, etc., and the overall implementation costs on how to keep the costs in check. Say, for example, you cannot add hardware on unlimited hardware to solve your big data problems. As we all know, the data has been growing, and the data growth has been really significant in the past few years, and not just in terms of volume, but also in terms of variety. The growth has been significant. So one of the biggest use cases we have seen is in our day-to-day life, we are seeing that our structured data use cases are outnumbered by our unstructured data, where we need capabilities to be able to handle log files, call logs, images, PDF documents, and all types of documents. So our unstructured data volume growth has been so significant, and the ability to handle such an unstructured data sometimes requires special compute like GPUs. We have use cases where we need GPUs to be able to run some of these use cases, and that is a bigger challenge, because creating a new GPU cluster or adding GPU resources on-prem has always been a challenge in our data centers. So these are some of the things, as we discussed, you might all be facing. And the second one is like the talent management. I just want to touch upon this, where there used to be a day where people used to learn one programming language, C or C++, and they would have survived their entire career. But nowadays, every second day the technology is evolving. People are learning new things. There are new technologies that require us to update our skills. So it's an extremely important thing that our business people that understand the business be able to solve the business problems or create solutions that does not require them to have any specific technical skill. So that's a big challenge we have been seeing. So in all of this, as we discussed, one of the things is the innovation velocity, time to market. We might be having the best of the ideas, but if we are not on time into the market with your solution, we are definitely going to lose out. So it is extremely important that it's not only having a good idea, but able to take it all the way from ideation into production and into the customer's hands. The time is what we are calling it as time to market, and keep it in a checked fashion. So that is where I think innovation velocity is extremely important for us. But while we are innovating, we cannot overlook the fact that compliance is being followed. We cannot, because we are in a regulated industry and we want our data to be safe, we want our solutions to be scalable, secure, and all of it. So it's extremely important that we also take care of the compliance. So we don't have the luxury of choosing one over the other. They both have to go hand in glove. So how did we do this? So this is where I think we are going to talk about the next problem that we have is the three-headed dragon is what we are calling it. So one is silos. While we are trying to solve this, on this journey we also identified that most of our teams are working in silos. Some of them are comfortable using Jupyter notebooks. There is the other set that is working only on Excel, and then there is a third set that is only dealing with documents. So similarly, like they are comfortable with their own tool set, and they don't want to explore other options. They want to be limited in their tool set. So how do we take them out of that silos? How do we give them the capability to be able to do much more than just operate on Excel sheets or just operate on Jupyter notebooks is a bigger challenge we try to solve. And we discussed about the compliance and governance. So sometimes whenever there is a new model development or a new solution that we are trying to develop, how many of you have dealt with MRM, model risk management, in a traditional machine learning sense? I'm sure you all have heard about it or dealt with it in your day-to-day life. So that's a big challenge. So the time taken from ideation to productionizing the model is sometimes less than the time taken to get your model reviewed through the MRM and getting the approvals, because MRM is a resource intensive and a time consuming process where every document, everything in the model has to have explainability, it has to be documented, and there were multiple scenarios that have to be run before the MRM gives us the approvals. So our intention was never to cut short the MRM scrutiny, but at the same time achieve the same MRM scrutiny within a shorter duration. And how do we do that is something we have started working with when we created a unified platform using Dataiku and Databricks. So we created one platform for our users and allowed them the flexibility or freedom to choose on which platform they want to operate and how do they want to operate, with some standard guidelines that we have already set up for the users. And one of the biggest outcomes that we have achieved out of this unified platform is the semi-automatic documentation of Dataiku has helped us to reduce the overall MRM process, and we were able to bring down the time taken for the MRM review. I'm going to give you specific examples in the next few slides, but this is the unified platform I was talking about. The biggest use case here is we have given the flexibility for our users to be able to make that choice, whether it is Dataiku, which is a low code, no code environment. People who do not know or understand programming languages or do not have the required skills, they are still able to get onto the platform and create complex workflows, create complex recipes. That is what we call it as. That is nothing but a solution on Dataiku, and also create some modeling. So whereas there was a time when modeling was always spoken in some secret rooms, saying you need data science background to be able to model, but we have democratized that model. That is what is the democratization we have achieved. I know you have, if you have attended the keynote, that is one of the most spoken word today, democratization. But we have been able to achieve that in real sense by creating a platform that allows people to create complex models without writing a single line of code. But at the same time, it also helped us to keep track or keep the audit trails of what they are doing, because that is how we have set up the platform, marrying it with the Dataiku capabilities and our own internal tools within Morgan Stanley that track the entitlements provisioning. We call it as EPR, entitlements provisioning requesting system. So it has its own audit trail. Everything is logged. If a user raises a request to get access to a particular attribute, that is logged and audited according to their entitlement provisioning. I'll also talk about RBAC, which is the role-based access control. So that's another thing we have achieved, but I'll just give you a high-level view. So with these two platforms, what we were able to achieve was we have achieved two levels of access at a very high level. One is ABAC, attribute-based access control, and the other is RBAC, role-based access control. So what does attribute-based access control mean? So at Morgan Stanley, we are firm believers of having least access possible. And in any given environment, we encourage people to go for the least access that is possible or required. So our attribute-based access control helps us to go at the granularity of a column level. It is not even at a table level. So if there are two PII columns, social security number and date of birth, and a user comes in and they only need access to date of birth, they will only get access to date of birth, and the social security number is dynamically masked. So that is the attribute based access control that we have achieved. And similarly, based on the roles, people can access data, and that is what we are calling it as role based access control. We are going to talk a little more about it in the future slides. Second, just want to touch upon the Databricks platform that we have created, which helped us solve the biggest problem, as we discussed. Challenge is scaling out the compute, scaling out special requirements or special compute that needs. Say for example, we are running a use case where we need to do signature verification, document matching and all, which needs GPUs, and all of those special use cases used to take weeks if not months to execute in our environment. But with Databricks, we are able to create those clusters on the fly, use them for the duration that we need, and then shut it down. So that has helped us change the entire game in this solutioning and the overall architecture. So I'll also talk about the Unity catalog and other aspects of it in the future slide. So I'm just I'll move on to the next slide. So this is the architecture we built. I'm going to show you the architecture diagram, but before that, I just wanted to give you a high view of how we are enabling our users to be able to choose for business reasons. They can start using Dataiku, where they can get access to production grade data. So that's another aspect of it. So as we discussed, we have created a sandbox environment, which is one of our use cases I'm going to discuss, which has a read-only access on the production data based on the user entitlements. If users have the entitlements, they will be able to see the confidential and PII columns, and if they do not, all those columns will be masked, and they'll be able to see the rest of the data. So that is how the Dataiku interface helped us, and we were able to move the same solution onto Databricks as well. With the help of Unity catalog and all, we are able to get the masking. We are currently working on the implementation of it, but we have already run the pilot of running the masking on dynamic masking on Databricks as well. So our users then just make one request, and they are auto provisioned on all our platforms. So because they do not have to go and select each individual platform. So it is a seamless access. If the data element is accessible for a user based on their entitlement, they can come through and access it on Dataiku, or they can go through Databricks and also access the same data element. So moving forward, I would like to show you the architecture. This is the architecture for our advanced data analytics and machine learning use cases. So let's start in the left. We broadly classified our user community, whether it is business, tech, or anybody, into 5 different categories. At the beginning of the spectrum is the data analyst, who could be a fresher joining the team in maybe Budapest or maybe in Shanghai, Hong Kong. They do not have an understanding of our domain data, domain knowledge, or domain data, or any of that, but they still have the need to create a dashboard. They still have to create a report for maybe the senior management, or they might even have to run a stress testing scenario, which is required based on the requirements that are shared by Fed. So that is how our data analysts operate. So, and on the far right corner, if you talk about data scientists, they are the PhDs of data science. They have full understanding of data science. They want to be able to write their own complex models, like two-tower models, DLRMs, and advanced algorithms that will predict, sometimes do predictions, and sometimes even prescribe the next set of actions and stuff like that. So all of these users are form our user community. But as you can see here, 80% of our users are classified into no code. They may code a little, but most of them, 80% of them, fall under the no code umbrella. And these people still now, in today's world, they have the capability, though they cannot write the code, they can do any of these actions. As you can see here, they can do a data prep, they can do data model development, they can even deploy models and all of it. That is because of the flexibility offered by Dataiku platform. The same thing goes again with the other spectrum of the users, like data scientists, the ML engineers, and the data engineers who might have created hundreds and thousands of pipelines during their lifetime. They have the ability, flexibility to come on board and start using Databricks, where they can write the code on the language they choose, whether it is R, Scala, Python, SQL, any language they choose. We give them the flexibility to bring in the libraries that are scanned through the X-ray, and they will be able to use those libraries, and they can create complex models. As you can see, at a functionality level, whether you're coming through Dataiku or through Databricks, your core functions remain the same. You are able to do the same activities by writing your own code or writing no code at all. So this is the architecture we have put up, but now we stretch this a little more further. As I said, I'll be talking about Unity catalog and data storage, and we have all kinds of special computes and all. But all this special compute is only available on Databricks. So what if a data analyst creates, maybe a very enthusiastic data analyst creates a model that requires GPU? That's a big question, right? So that is also a problem we solved by using what we call it as DB Connect. So that's a special connector from Databricks that helps us to run any workflow, recipe, or a model that we generated on Dataiku platform. We can push that down into Databricks and use Databricks as an autonomous compute. So it's just a compute layer. So you do not have to write the code on Databricks. You can still write the code on Dataiku and use the DB Connect to push the data, to push the processing of that particular workflow or model onto Databricks, and it executes using the special GPU clusters of Databricks. So that's the next big thing that we have done, which has helped us to maintain this platform in a very flexible manner. So it has helped us, again, just to give you a high level number, it has helped us launch close to 40 models using this architecture in a very short span of 12 to 18 months. So moving on from the architecture, I would like to discuss a few use cases as we are going through this. The first one I would like to show you is the sandbox use case. As we discussed, sandbox or playground, we call it both the names. It is an environment where which is created to allow our business users to access production data. So if any data that is on prod, if they need to run any report or if they need to create any model on that, they can access it through the sandbox. The way we have implemented it is platform agnostic. It's a concept for us. It is not specifically linked to any one platform here. We're not just talking about, say, for example, Hadoop, Teradata, Snowflake. So whether you are on cloud, whether you are on-prem, so some of these are on-prem. Like, say, for example, our Hadoop and Teradata still reside on-prem, and our Snowflake is on cloud. But irrespective of that, the sandbox architecture is spread across all our data stores. Whether it is Hadoop or Snowflake, we enable them, we create views on the production data that needs to be exposed and grant access, read access on the views for our sandbox users. Now they can take that production data and start creating their own versions. And just to give you a number to put it in context, they create close to 100,000 tables per week. For every 5 days, they create 100,000 tables. We have a huge set of business users that are using this sandbox. That is around 1,500 to 2,000 business users are using our sandbox environment actively. And on a weekly basis, they create 100,000 tables that they keep reiterating. They change one parameter here, one stress scenario there, and they keep recreating the data in multiple iterations. They transform, they curate, they create it until they are happy with the output. So we have our own retention policies and all. On any given day, our sandbox data that these people create is almost equal to the size of our production data. So because sometimes they create these data and we need to retain them. So we have, again, that's a different discussion for a different day, but we have a beautiful retention system and all where people can go and self-define retention policies on the sandbox data. And if they don't define any retention policies, we just drop the data because it can be recreated by rerunning the workflow. So the second point I would like to touch upon here is how we have implemented sandbox is another story where we have created 250 projects. We call them PRJs. So we have created 250 projects. So all these 2,000 business users that we are allowing access to them, they come in with their business use case, if there is a new requirement, and if we have a discussion, architecture review discussion, and if we deem, we create a new project for them or repurpose an existing project. And these projects, they all work in their own swim lanes. There is no cross-pollination. Yes, they can share the data, but sharing of the data or collaboration of the code has to happen with approvals. But otherwise, everybody is in their own swim lane. They start using the environments. As I said, these projects are created across all the platforms that are available, whether it is Dataiku, Databricks, Hadoop, Snowflake, all these platforms have these projects, and they are able to run their stress test scenarios. They are able to run their Fed regulatory reporting. They are able to run their machine learning models, all of those using these projects. And we did discuss about the attribute-based access control, role-based access control, and how we are maintaining the integrity by only granting them read-only access. All of that is what is followed through the audit trail. Everything is tracked and logged for any auditing purposes. Moving on, we are talking about the use case number 2. This is an interesting use case about a risk model that required, I'll start with this number here. As you can see, this model used to run for weeks together. The people used to run these models. They used to go home and come back and check on Monday. They used to run it on a Friday, go home and check, come back next week and check if the model actually executed or not. And more often than not, they used to have failures. These are some investment office models and all that we have, global investment office and other things. So these were really, really resource intensive, and they created the biggest hardware machine available, physical machine available on in all of our data centers. Even then, the model used to take days. So what we have done is we have worked with the business. We have taken the model, rewritten some of the code using DevGenAI and other aspects of it, and we were able to transition that model into this unified platform and create auto-scaling clusters using Databricks and parameterized workflows using Dataiku, and we were able to bring down the overall execution of the model from weeks into less than 30 minutes. That is because of mainly two things. One, when they were running these models on-prem, they were not using the distributed compute capabilities. They did not have access to them. They did not have access to that kind of resources. And since we were able to bring them onto the platforms where they had access to distributed compute, and they were able to use special computes like compute intensive or memory intensive clusters and all, we were able to bring down the overall execution time, and now the model runs in less than 30 minutes. Moving on, the third use case I would like to discuss is the stale reports. this is another interesting use case where our business requires us to create the users to create a lot of reporting and dashboards. The underlying data was becoming stale for them because they were not able to, as you can see, they were not able to run these reports on terabytes of data. So that was a big blocker for the business, and we resolved it again by enabling them on, we moved the dashboarding onto Dataiku, and we moved the terabyte-scale ML running onto training onto Databricks. So now as I said, the dashboard resides on Dataiku, but the underlying training actually happens on Databricks for real-time data. So that's a big jump for us. And now there is no more stale reporting, and all the reports are run on real-time basis and in interactive mode. If they need to change something, some parameters and pass additional features, they do that and rerun those reports on the real-time data. In the interest of time, moving forward to the fourth use case. So this is the model we discussed, I briefly touched upon, where there are documentational needs. There are MRM requirements for every model, and the way we have created Dataiku role-based access and attribute-based access, some of these have been standardized in such a way that while the model is being built, we started generating documentation. We started creating the documentation based on what is the model, how the access has been granted, how the entitlements are being governed, and how the PII elements are being masked so that the model does not use any PII elements in case if the model does not use, or if it uses, it will also tell you what are the PII elements the model is using. So that is how we are able to bring down the overall documentational lead time and be able to generate models that are ready to be audited once the model development is done. So this is another use case which has helped us to bring down the overall time to market and create models that are almost at a phase where we can say 60 to 70% of our data or the documentation needs are being auto-generated. We do not have to invest people, we do not have to invest that kind of a time that was previously needed. As I said, 100% of the audit readiness, in that 70% whatever we are doing, all of that does not, we just have a human in the loop to make sure things are not going haywire, but most of it is auto-generated, and that is 100% audit ready. Whatever the documentation automation that we have achieved using Dataiku and Databricks, that has helped us. So you have seen the use cases, you have seen the platform, you have seen the architectures. So what does it mean for us in the long run at a very high level, right? So it helped us. These platforms really helped us to reduce the time to insights by 50%. We are able to run some of these reports and some of these models without worrying about the next set of hardware, or without worrying about the concurrency, or without worrying about the overlap of process. So we still have scenarios in our data centers where we run sequential jobs because we only have limited capacity, and all of that has been resolved. And it has also helped us to bring the business teams and the tech teams and our model risk management team closer, because there is no friction now. We work very collaboratively. We are seeing that people tend to flourish when they have options and when they get multiple of these platforms which they do not need specialized skill sets, which do not need them to depend on someone else to fulfill their timelines. There was a scenario where people were used to wait for other tech team to create a dashboard or tech team to help them create a model. Now the business team can start doing these things on their own. They have become self-reliant and independent. And from the tech side, we have the balanced governance. We have balanced the agility with governance. because we know that we have processes in place, we have the data segregation in place that requires us to govern these platforms very well. So if we are able to achieve analytics, scaling analytics without compromising on the compliance is the biggest win for us. So as is the case with every single project that we have implemented, right? We always will have lessons that we can learn. What do we learn from all of this, and how do we make sure that we carry forward those lessons? Is as one of the biggest things is we were able to implement or leverage no code capabilities of Dataiku, and we did not add anything on the risk side. If you look at the balance of it, we were able to expand our feature set, expand our capabilities, but at the same time keep all kinds of risk to a minimum. That's number one. And number two is the overall collaboration between the teams. Now people can start creating a workflow or a recipe that they can share with the global team. So we follow the Sun model, where the team comes in Asia and are able to pick up from where this North American team has stopped, and they can continue the work, and they are able to follow the Sun model. They are able to understand each other's work, because most of it is visual UI driven, and they are now able to even share the clusters that we are creating on Databricks, or even have their own independent clusters depending on the criticality of the project. So previously we have known scenarios where people used to talk to each other and say, hey, I'm running this job, please hold all the other jobs. So that is a thing of the past. Now people are able to have their own independent clusters where they can run their jobs. It also helped us to kind of achieve a cultural shift. Okay, as we discussed, it has empowered our users to do more and do it quickly. You don't need to depend on anyone, and it also helped us to bring from silos into a collaboration model. So in the interest of time, I'll just move on. So what can you do in your environment? How do you take this model and replicate it, right? So this is something which is really close to my heart, and all we believe at Morgan. We learn from each other. We learn. That's the whole purpose of coming to these conferences and all. We learn from each other's experiences. So definitely, this is something I would recommend. This is how we started. We had conversations with our peers in the industry. We understood what are the technologies that are available and how do they fit into our ecosystem. That's number one. But then start with identifying your own silos. What are silos? So I discussed all the silos that we had, but yours could be a different scenario. But definitely there would be silos. There would be a duplication of effort. There would be reinvention of the wheel happening in your teams. So identify those and try and standardize it. Try and bring it into a standard on how it can be avoided. So I'll give you a quick example here. So during modeling, right, there is something called as feature set generation. I'm sure most of you are aware of it and use it. So all our users used to do their own feature set creation. They didn't even talk to someone sitting next to them to see if someone has already created a similar feature set. So that was the silos we were talking about. And now what we have done is we have brought it all into one feature store, where we said nobody else gets to create feature stores other than one central team. You all can subscribe to features. You can reuse the features and avoid your own pipelines. And that helped save close to 4,000 hours of man effort per year. So that's the kind of impact you can create by moving the small needle a small way to the right. So that's something you can do, and find a pilot that you can start using, test it out quickly. So most importantly, test quickly, fail quickly, restart. So that's the most important thing. And we have done, we had challenges, we had obstacles. So that is where you need to create smaller goals, smaller objectives, achieve them, move on. Create multiple milestones rather than having one big target. Create multiple milestones. So after you complete milestone 3, if you fail, all you have to do is restart from milestone 3. You don't have to go back from scratch. Okay, and last but not the least, as I said, join the community. So we all are here, we all are learning from each other. These are opportunities for us to share each other's success stories and learn something. Thank you very much for your time. I really appreciate you all making this journey from Moscone to here. I really appreciate that, and I'm available here for any questions.